Hi, and welcome to Mr. Garofalo's podcast. In this episode, we are looking at Common Core Algebra homework for sequences, problem number 1, letter F. In this problem, we're asked to write a recursive definition for the sequence A of n. The sequence is given at the top of the page here. And remember from class, a recursive definition is one in which we are told to find the term number by using the term or terms that came before it. So if you look at this sequence here, you can see that it looks like we're adding 6 to get to the next term. So if I asked you for, say, the 20th term in this sequence, if you're using a recursive definition, you would need to know the term before that, namely the 19th term. Now let's look at from class how we wrote a recursive definition. If you go back to exercise 3, you'll see we were given a recursive definition and asked to write a sequence from that. So we need two parts for a recursive definition. We need to first state what the value of the first term is. So see from class we had b sub 1 is 7. And then we need to say what we do to the previous term. And that's what this part is right here, where it says b sub I equals b sub I minus 1 plus 4. So we're going to try and write this form for our homework problem. So let's first start with the first term in this sequence, which would be a 1. So we would write a sub 1 is equal to 1. And I'm getting that right here from the sequence that's given. Okay, there's our first term, a sub 1. The rest of the definition comes from what we need to do to the previous term to get the next term. So we would say a sub n, which sequence a for any term number would be equal to, well, we see that we are adding 6. So we need to add 6 to the previous term to get the next term. So for instance, here we have in the third term 13. Well, how did we get 13? We added 6 from the second term. The second term was 7. Okay? So this definition would say a of n minus 1. What that means is if you want to find the value of the term, you have to go to the term that's 1 before it, and then once you get there, you add 6. So the definition recursively is a sub 1 equals 1, and a sub n equals a of n minus 1 plus 6. And once again, it says the sequence starts with 1. To find any other term number, take the term number, go back one term, and whatever's there, add 6 to it. Let's also look at problem number 5. For problem number 5, we're given a recursive definition. So we don't have to write one here, but they tell us that a of 1 is 1. That means the first term in this sequence is a 1. So how do we interpret that part of the rule? Well, very simply, the first term is 1. And the rest of the definition says that a of any step number, a of n, is equal to a of n minus 1 plus n. So it says to find any step number, you have to take one less than that step number, so step number minus 1, and add that term number or step number. So the rule has two parts. First term is 1. Each term is the sum of the term before it and the term number itself. That term number itself is coming from right there. Underline that. So let's try one using this recursive definition. So we know a of 1 is 1. Now we're asked to find a of 2. Sorry about that. So a of 2 is going to be equal to a of 2 minus 1 plus 2. Now I got that by substituting in a 2 here and a 2 here. Again, we're looking for term number 2. So we need to look for term 2, 1 less than term 2, and then the sum of that term. So a of 2 would be equal to a of 2 minus 1 is the first term. And the first term had a value of 1, and the term itself is 2. So a of 2 is equal to 3. So you're going to continue this process along for 3 and 4 as well. Good luck on the rest of your homework, and see you in class.